Okay, so there's just a very specific thing that I'd like to review and something that's going to come up more often, and that's just using a table to come up with an equation. I know we've gone over it before, but I feel like it needs to be emphasized because you need to have as many avenues as you can to be able to navigate linear equations, okay? So we know that we can find the change in y over the change in x, okay? And that's where the slope formula comes in, y2 minus y1 over x2 minus x1. And all that does is take some work organization. You can mark this x1, mark this x2, y1, y2. And you can find the slope. So the reason I didn't choose the 2 is because there's not a y coordinate, so I couldn't find the difference between something I don't know. Um, so that looks like 1/2. You could also plot the points onto a grid, and I have the grid here just to demonstrate 0, -3. So we got a y-intercept already, and then 10, 27 about why we can't use the grid all the time, and it pays to know how to use the table because already I can't plot 10, 27. So the change in y from -3 to 27 is plus 30. From 0 to 10 is plus 10. So now I know I have 30 over 10, which equals 3. And I was already given a y-intercept because x is 0. That's convenient. So far, here's what I've got. Y equals 3x minus 3. And the question is, what is the y value when x is 2? And that's where the substitution is going to come in. Okay, so here's what you got. Y equals 3 times your x value is 2 minus 3. Y equals, follow the order of operations, 6 minus 3. Y equals 3. So this would equal 3. We just solved that problem. Okay, so we could also plot 2, 3, and test up 3 over 1, up 3 over 1. Check. This is a line. This is exactly what it needs to be. Cool. A lot of work and a lot of stuff, but there's a whole bunch of steps it included, and they're all linked together. Let's take a look at when we're given just another table. Okay, so I'm going to cover this up because we don't need this, and we're not going to use it. What if this is all you're given? So we can go from 0 to 4, but we can't. Oh, see, now we can't. So we have to go where we have both coordinates. Okay, so 4 to 9, that's plus 5. 9 to 31, what? I'm just going to go ahead and just get out a calculator. I don't even want to think. So 31 minus 9, 22. That went up by 22. So 22 over 5. Okay. And it's asking what's the y-intercept. Oh, geez. So y equals 22 over 5x. It's going to be plus or minus something. So if we put in 22 over 5 and plugged in 4 for x, so let's do that. That would be 88 over 5. Let's go calculator again. So you can see the process I'm going through. I'm using the pieces with what I've got, which makes sense. You're like, yeah, no duh, Foster. Okay, so 88 divided by 5 give you 17. Okay, so we got a big 17 and 6/10, which is 3/5. 17 and 3/5. Wow. Okay, so that is plus 17.6. It doesn't matter what you're given in the table, you can do this. And I wanted to give you this extremely weird one just to prove that 22 over 5x plus 17.6 could be a linear equation. Pretty weird stuff. Now I want to give you one that's a little more straightforward, and just to go ahead and use the pieces you've got. Okay, so plus 18 plus 9, you got 18 over 9. That's your y over x. That equals 2. So now we've got y equals 2x. We already know that when x is 0, our y is 0. So that is the equation. You could put plus or minus 0, whatever you want to do. So these are just the things that I just want to keep on emphasizing, that the resources you have and the ways that you can do this, you really never run into a dead end.